Okay, Assalamualaikum. Now we are going to proceed to the next chapter. Okay, chapter 2 or chapter 16 from your textbook about waves motion. Now, to name a few, right, we have many types of waves. Okay, we have light wave, sound wave, or even light from the sun. Okay, as it reach the earth, okay, it will be in the form of electromagnetic wave. All right. So in this chapter, we are going to see the characteristics of wave, right? But first, to analyze it, we are going to analyze it by using a string, right? So we are going to generate waves by using a string. All right. So how? Now, when you refer to figure 16.1, right, we have a string, and the string is known as the medium, right? So first, when we want to analyze ataupun to generate wave, right, first we need a medium, right? In this case, the string itself is a medium, right? Next, okay, we need a disturbance, all right, disturbance. As you can see in figure 16.1, all right, sort of disturbance here is coming from the hand itself, all right. Okay, the disturbance ni meaning something like a external force, okay, that we generate, okay, the wave, right? And the third one, okay, is the third thing that we need, okay, to generate wave is the mechanism, okay, mechanism, okay, mechanism, okay, on the mechanism of the particles, right? But in the textbook here, it use the word elements, right? So elements here resembles the particles in the medium, right? So the mechanism of the elements, okay, to influence other elements ataupun to influence neighboring elements, all right? Neighboring elements, all right? Okay. Now, so in figure 16.1, before we apply force, okay, to the string, all right, there's nothing happen. Meaning the elements or the particles, okay, of the string remain at their equilibrium positions, right? But as we stretch, okay, the string up and down, what happen? It will cause a pulse, okay, that travel along the string. Alright, so the pulse is produced as a result of the elements or the particles are displaced from their equilibrium positions. Okay, in other words, we can say that the particles are vibrating upward and downward. Right, so as it displays upward and then downward, the energy from the vibrations of the elements will be transferred to the neighboring elements, as you can see here, right? So here you get you can see the elements here is vibrating up and down. Once it go down, you can transfer to the other element as well, all right, until it reach the end of the string. Alright, so from here you can see that the vibration, okay, of the elements ataupun particles is perpendicular, okay, with the propagation of the wave. Alright, so the vibrations is upward and downward, and at the same time, okay, the wave is traveling to the right. Okay, so where every time you see that the elements is vibrating, okay, perpendicular to the propagation of the wave, right? So here you can see that transverse wave is being produced. Okay, transverse wave, right? So one example of transverse wave is the wave that we get, okay, when we plug a guitar string. Okay, so for example, a guitar string, right? So you can bila you plug guitar string, you know, okay, the movement of your fingers, isn't it? All right, it is perpendicular to the direction of the wave. All right, okay. Now, the wave motion, okay, is also known as a transfer of energy, because as it is moving to the right, okay, the energy is being transferred from neighboring particles to the other particles, right? Okay. Now, next diagram, okay, you can see that, okay, here we apply the external force, okay, in a different way, right? So here we can see that, okay, the force applied at the end of the spring, okay, is to the left, either to the left or to the right. If we pull it, okay, pull it like this, okay, to the left, right, meaning we stretch the spring, isn't it? If we pull it, okay, towards the spring, meaning we compress the spring. All right. So as a result, okay, when the hand is moving forward and back to create, to what we call it, okay, to change, okay, the displacement of the spring. So at the same time we have created the different pressure in the spring, isn't it? Right, there is a region where we call it as low pressure region and high pressure region, right? And here the vibration of the elements in the spring, okay, the vibrations, okay, of the elements, okay, is now, okay, is now parallel, okay, is now parallel, okay, to the propagation of the wave. All right, is now parallel to the propagation of the wave. All right. So remember we have the third requirement here, mechanism of the elements to influence neighboring elements. The word mechanism here represents, the word mechanism here meaning either it is perpendicular ataupun parallel. All right. So in this case, in this diagram, alright, mechanism ni adalah, okay, the elements will transfer energy, okay, secara parallel to the other neighboring elements, alright. Ini mechanism dia, okay. So vibrations of elements, okay, is the direction of the vibrations, okay, is parallel to the propagation of the wave, alright. So as a result, longitudinal wave is being produced. Alright. Now, one example of longitudinal wave is sound wave. Okay. So, sometimes bila kita buat speaker, nampak tak kalau kita buat apa, buat apa simbol sound wave, you have something like this, isn't it? Alright. Okay, kenapa? Ada makna di sebalik simbol ni. Alright. So, yang ada line ni adalah the high pressure region. Okay. Pressure untuk apa? Pressure untuk air particles, right? Ataupun sometimes we use the word high air density region ataupun low air density region, right? So the gap, okay, the gap between lines ni adalah, okay, the gap between lines adalah region apa? Region low pressure region, alright? So this is sound wave, right? Now besides these two, transverse and longitudinal wave, we also have a wave that combine these two. Alright, for example, tsunami. When tsunami occurs, it combined transverse wave and sound wave. Right? So you can read more detail from the textbook, okay, about the wave that combine these two. Alright.